I'm asked to solve for x here, and probably my favorite technique is using completing the square. However, I don't typically use completing the square if my x squared coefficient is something other than 1. And you can see here I've got 2x squared. So I'm going to attempt to factor this. I'm going to use the zero product properties to solve for x. So I will start with a generic area model and a diamond problem. For this I have 2x squared and 15 on one diagonal. That has a product of 30x squared, and I need to find values for the other diagonal in my generic area model that also have a product of 30x squared, but they have to add up to negative 13x. So that's the diamond problem, right? Find two expressions that have a product of 30x squared and they have a sum of negative 13x. The number 30 is, I'll write 1 times 2 times 3 times 5. So I'm looking at the prime factorization of 30, and I can consider those factors 6 times 5 as I build my my two things for my diamond problem. I know that one of them, actually I know that both of them need to be negative, don't I? Because I can see I have a negative sum and negative 13, and I have a product that's positive 30, so both of these have to be negative in order to get that situation to occur. And if I think about it, I'm looking at 10 and 3, so negative 10x and negative 3x. Those definitely have a product of positive 30x, and they definitely have a sum of negative 13x. So I'll write each of those here, negative 10x and negative 3x. Along the bottom, I've got a greatest common factor of just the x, so I'll bring that out. As I go down, I can see both of those have a common factor of 2x. I'm going to write a 2x here. Along the top, I can bring out, I guess, a factor of, it would have to be 5, and actually a negative 5. Yeah, because negative 5 times 2x is negative 10x. And then the other, going down, I'm going to have to bring out a negative 3. So if I'm just checking here, this 2x times x is indeed 2x squared. Okay, so that checks. Also, negative 3 times 5, I'm sorry, negative 3 times 5 is 15, so that checks. And then the other ones are, if I multiply x and this negative 3, I do get 3x, so that checks nicely. And the other one is when I multiply this 5 with this 2x, I do indeed get negative 10x. So that all works quite nicely. So I know now the factored form of this quadratic. I can rewrite it as 2x minus 3 times the quantity x minus 5. And that equals 0. I was told it would equal 0 up here originally. So again, the zero product property, if you have two things that have a product of 0, the only way that's possible is if one of the factors equals 0. So what we do with the zero product property is we're going to set each factor equal to 0, and we're going to solve for x independently. So if in order for that first factor to be 0, 2x would have to equal positive 3, and x would have to be 3/2, or 1.5. And in the other case, x would have to be positive 5. So our solutions here are x is 3/2, 1.5, and x is 5. So we definitely have solved for x.